Okay.
Share,
So I have
share
a
your screen.
challenge. I have a challenge.
What's the
Like
challenge?
I was not able to deploy, like so many errors. Ah, God.
Share your screen. Let's see your errors.
Okay. I'm coming. Let me share my screen. Can you see my screen?
Yes, I can. So what's the error?
Okay, I don't have error in my contract. Like I was trying to, I think where the whole challenge was coming from was trying to get my API key, was trying to like deploy and all, get my address and all. I think that is where I'm still stuck, sir. But in my contract, like I've been able to do it. And why?
Let me
Although
see
I
your tests. Let me see your tests. Run npx Hardhat test. Let's see. Increase the size of your terminal.
okay.
Mhm.
I think it's network.
I'm seeing your screen clearly. It's not network. Hmm. Hmm. You wrote this code yourself?
Yes, I did.
Okay, unexpected error. What's wrong?
I don't even know, sir. Like I'm so stuck now. Like I've been up since.
Go back. Go back. Let's see.
Okay, cannot find. But I installed this now. Nomic Labs had that. This is what it's saying. Cannot find module. Nomic Lab had that. It has scan.
Open your Hardhat config. Why is your folder structure looking different? Your folder structure is. I don't understand your folder structure. Go and close blockchain from the left. Go to the left panel. Yes, close that. No, come down. Yes, click on that arrow. Good. So why is your Hardhat config? Okay. Open it now.
This one,
Open it.
right?
No, not that.
That that's my
Wait, go back to the end of your terminal. Yeah, press L and type ls
NX or
L
NS.
L L L L
Okay.
M L S L like a lion, then S. Yes. Press
Okay.
enter. That is a Windows, Abby.
Yes, that is the thing. Ah,
Scroll up a little. Let's see something. Are you sure you're okay? You're inside blockchain project and you have everything. Run npx Hardhat compile. Did you clone this repo or you initialized it yourself?
okay, this particular one.
Yes. Yes.
Okay, I took it. You know, you gave us a Git where we could
Yes. So
want. Yes, that's where I got it from. Then
so
I
you
imported.
okay.
Yes,
So did you run npm install?
npm install. Yeah, I had done it before.
Before on the same file?
Yes, like I done it before on the same site. So I don't even know where like I just
I
ran
don't.
the NPX Hardhat now.
Wait. Go back. Go back down. Go back down. Yes, chill. Modules TS index.ts not found. Are you sure? Did you clone it? What did you do? Okay,
I didn't
go
clone it. Like you said, if we wanted to deploy, we could use that. That was what you said. So I just took it from the one you gave us on GitHub.
comment out line one. Let's see. Line one, comment it out.
Okay.
Comment line one out. No. Go to line one in Hardhat config.
Okay.
See it,
Hardhat.
you are in the file, yes.
Yeah.
Then
Line one.
control, yes. Then you do control backslash, control and backslash code. Comment it out. No, you did two. Is it control and backslash? Those double line is supposed to be in front, not at the end.
Okay. Yeah. Right.
Mm-hmm. Mm-hmm. Okay, I tried. Let's see.
That is the LS or NPX Hardhat compile.
Compile it.
Okay.
Okay, the error has changed. That is not found in this. Do npm install.
Okay.
Hope the rest of you have yours ready because I'm going to call the next person randomly. Okay, I try and compile it now. Just press up. Press the up arrow key. You don't need to be typing every time. Press the up arrow key
Okay.
on your keyboard. Press it again.
I
You
should
can press
enter.
enter. Yes, you can. Yes, you don't need to be typing all the time. I can press up. Okay. I don't know what's your. I don't know. I don't know.
Mm.
What's wait? Not that I can also. How that is not okay. One on comment the line one.
Okay.
On comment the line one. I don't know why the error is coming from your Hardhat config. I run it again.
That's the compile.
Yes, compile it. I want to understand the nature of your error. It's giving me headache. Is this what it's saying again? Not found. How, like, okay, go back to the repo I gave you. Go back to the repo I gave you. Open your browser.
Okay. Um,
Hurry up, hurry up. I want us to see at least two more
yeah, I've
people
gone
on.
there.
Is that?
I've gone there. I've gone there.
I cannot see it.
Okay. Sorry. Let
Wait,
me
someone is saying, wait, go back. Someone
see
is
my
saying you're
screen.
using it. Yes, go back to the to your terminal. Someone just said you're not spelling Hardhat correctly.
Okay.
Hardhat is H-A, let's see, press up. Okay, H-A-R-D, yes. You're not spelling Hardhat correctly. You're using, you're
Okay.
spelling
So
it. Go back
which
to
of
your
the line?
terminal.
Yes,
Go back to
I'm
your
my
terminal.
time now.
I
Okay.
type npx. I space Hardhat, Hardhat. Yes, that's how I spell Hardhat. Compile.
Okay.
You've been spelling
Okay, I've been spelling it
Hardhat.
wrong.
Yes, you've been spelling
I've
it wrongly.
had that. I've had that.
Okay, still saying module
Thank
not
you.
found.
Yes.
Mm-mm. Wait, it's still saying module not found. What's wrong with this? What's wrong with this? Thank you. Sorry. Um, say, oh God, oh God. Wait. Go back. Open the my blockchain project folder. Let me see the folder structure.
Okay.
Yes. No. Yeah, come down. Yes, open that. Um, wait. Close your type chains. Close your tests. Close your tests. Okay. So what's wrong with this? What's wrong with this? Someone should look at that folder structure. Is anything wrong with it?
So it's possible because like the first time I installed my Hardhat, so
Mm-hmm.
they said that my node version is too high, like it's 23 and version 23 that is not compatible with it. So I uninstalled it and then I
Mm-hmm.
installed version 20. So when I did that and I installed Hardhat back, it didn't show me all these folders. I had to use like I had to do some in the terminal, like I had to put some code in the terminal for it to bring out this terminal. So I think maybe that's where the problem is. This
Okay.
maybe
So
that's
I'll
where
leave you. I'll
the,
leave you. Go back, clone the repository. I want you to go back and clone the repository again. Then
okay.
don't delete this. Then you just copy your code and paste in the new one. Clone the repository. Run npm install. Then I'll come back to you later. So okay, who is confident enough to go next? I want to see hands.
Sorry,
If I do not, if I can stop
let me stop
presenting.
sharing.
Yeah. Who is confident enough to go next? Who is confident enough to go next? Nobody. Okay. Who would I call? Oh, okay. So yeah, let me start alphabetically. Okay. Are you on the call? If you're on the call, mute your mic, share your screen, and show me your assignment. Abubakar is not on the call. Okay. You should note Abubakar did not this assignment. Oh wow. Wow. Okay, you have something yesterday. So and the next person left the call. The next person I was supposed to call left. Sure, we'll come back. Then let's see. The call is light. I'm not seeing many people. So okay, let me work with people I know. Obed, Chuku, Obed,
James, sir.
Jem Obed. You are not the one that
Yes.
was traveling yesterday now, were you?
No, I was not in yesterday class.
You are not in yesterday's class.
Yes, sir. I was busy with something yesterday. So I haven't finished my own assignment and my laptop is off.
I didn't see you in yesterday class, yeah, sure.
Yeah, it's only the beginning section. When Kanimo is presenting his project that I came in and left.
Okay, Sandy, you in the class yesterday. I sent you your NFT yesterday too. I know it's Johnson. Someone should reach out to him. Not in class. Sandy, share your screen and let's continue.
So currently, my system is not with me. I'm joining with the phone. My system was
Yeah,
switched off.
yeah, yeah. Oh, good. Sandy, wait.
Okay. Yeah,
Sandy,
James,
Sandy,
sir.
Sandy,
James, sir. Getting
Sandy,
sir.
Sandy, give me a minute.
Okay.
Ade Bakin Olu Jumi. You're the one that ran out. Welcome back. It's your turn. Share
Sir,
your
please,
screen.
I reached out to Johnson already. He said that he had an emergency, he went to do something somewhere, so he cannot join the call, but he's going to come back and join the call.
Okay. So yes, Ade Bakin Olu Jumi. Not see your screen and your assignment. Oh, silence. Sandy, please, let's continue. Sandy, please continue. Sandy John.
Okay. Yeah. I'm about
Okay.
to. Trying to. I don't know why I'm getting error. Trying to.
Okay. Let's see why are you getting error trying to present your screen or doing the assignment you try?
Trying to compile the assignments.
Okay,
Maybe.
let's see.
Maybe
Let's see. We'll fix it.
test it. Sorry.
No problem, we'll fix it.
Let me share my screen.
You see, sometimes even if you have errors, that's why I demand to see your assignment. So if you have struggles, I can help you fix it. And by doing that, you learn and others learn. Or when you have nothing to show,
Okay,
yeah, okay.
this is it. I didn't get the link to the GitHub repo yesterday. I couldn't get it, so I tried to follow the video and write it. So probably I wrote the test for the giveaway and trying to compile it. This year I get
Okay, the project cannot be compiled. With the Solidity version in this file do not match any of the. It's simple now. It's simple. Yeah, it's
I
simple.
I tried to change the version.
Just wait. You don't need to hurry. Now let's take me back up. Let's read the message where it says the Solidity version does not match. The Solidity version pragma in these files does not match any configured compilers in your config. Change the pragma or configure. Yes. So go back to your lock.sol, it's 0.2.0.8.28. Okay. Go back to your staking contract, let's see.
Okay, I'm
Okay,
trying to.
go back, don't worry. Go back to log.sol. No, go back to log.sol, change it to 2.20. Go back to Hardhat config. Go to Hardhat config. Change it to 0.20. Okay, compile it now. And this other, I shared the Hardhat config.
It's an invalid version.
Wait, chill. Have you tried compiling it?
Yes, sir. This is error message.
Uh, okay, go back to line 5. You're not supposed to go back to line 5 and take away that's number 6 something. That is it, what did you that thing that looks like a heart. Take it away. In line
Number
6,
6.
in line 5, in line 5. In line 5, after the first quote, there's something that look like a heart that you put there. I can see it.
Which
That's
of it?
That's line 5. Go to the quote before that. Yeah, that symbol, that special character between 0 and the open quotation. Take it
Okay.
out. Yes, that's guy. Yes, I can compile your code again. So you see, we'll fix the error. So let it compile. Yeah, don't worry. We'll do this thing. Because once it's 10, I'm going to a new topic. So that's what I'm going to fix everybody's error now. And
Again, error from contract giveaway. Contract giveaway. The compilation failed. Expected from the contract.
yeah, open your node modules. Let's see if you have OpenZeppelin.
I think I installed it.
Okay, I can see it. You're going past it. Go up. It should be up at OpenZeppelin.
Yeah.
Yeah, I can see it. So what's wrong? Imports. What's it saying? Scroll up. Let's see. A little. Scroll up a little. Let's see what okay. Oh, is it where the error started? No, come back down.
This is
Hash
where it
error
started.
expected from.
Out.
Okay, go and add from import ERC20. After go back to your creator. So after you put ERC20, then you put from. Yeah. Okay. From. Yeah, do the same thing for enable. Okay, let's try it now and think.
Still the same thing.
Don't worry.
Oh God.
Just
Yeah.
calm down. Wait, just calm down. Line 10, line 10. Go to line 10. Okay, I see like go up. Line 10 is not supposed to be a comma. It's supposed to be a semicolon. Just compile it again. You see, what I notice is your problem. You guys, problem is you guys don't read. You guys don't read your error messages. You just said, I'm having error, I'm having error. You start panicking. Once you read, and what's it saying now? Line what?
925.
What's it saying? Expected forgot. Okay, line 25. You see, line 24. Go back to line 24. There's no semicolon in line 24. Are you see? So if you have an error, you don't just say I have an error. You read the error, what the error is telling you. 90% of the time the error fixes itself. So you see, you see now you are using box. It's not box, it's supposed to be parenthesis, the one on top, number 9. That's what you're supposed to have there. You understand?
Yes, sir.
That open and close parenthesis is not box braces. And then you change it at the end. Yeah. Compile again. So good. Different number of arguments, the return statement. So what are you returning? You're returning an address. Yeah, no. There's no returns. Go after public. Go back. Go on line 28. After public, add return. Returns. returns. Add an S. Add an S. So that return. Yeah. Returns. Then open a curly bracket. Then open a parenthesis. Sorry, not curly. Parenthesis. Close it. Open parenthesis. Then in between the parentheses, address. Type address in between address. Yes, you specify the return type. Okay, compile now. Hope you guys on the call are paying attention. So what's it saying? Okay, return argument type boolean is not explicitly converted. Go back up. So you have to return 1. WON. Go back. It's not winner. Wait. There's an error. Go back up. There's an error. 1. Change the boolean in line 9 to address. Yes. Then let's go down. Go down. Yes, that one should run now. But wait. We've not updated. Wait. See, let me just give you. Go to github.com/aj70. You should see this repo. I don't need to stress myself. Go to github.com/aj70.
Sir.
Github.com. Yeah.
Please, can I share my screen? My laptop is about to trip off now. My laptop.
Okay. Yeah. Do that. Sandy, go to you see the repo. You see the repo. The repo is titled FinTech.
All right.
Then open it and you put the information you need. AJI70. I cannot see the 70. Yes, that's my. You see the repo. Click on repositories. Click on repositories. Yeah, the first one. Yes, the first one, not the second one. Ignore the second one. The first one. Yes. Then you can go to contracts, giveaway.so, then you pick up the code, enter contract. Okay, whose laptop is about to die? Share your screen. Stop presenting. I'll get back to you, Sandy. Okay. Okay, whose screen am I looking at?
Jesus, I got stripped off. I have
Okay,
to
okay.
join with my phone.
Oh, yeah, your laptop has stripped off.
I have to join with my phone now.
Okay, so you cannot show us what you've done then.
Hello, sir.
Yeah, Christiana.
My own is 10% too. And I don't want it to trip off. So I'm just taking permission to join with my phone because I don't usually let it trip off.
Okay, you can join with your phone, but you guys are defeating the purpose of this class. If you come to a hands-on class and you want to join with your phone, you are joining with your phone, she's joining with her phone, then, well, you can join with your phone and, yeah, okay, there's a video, so you can watch the video later. Cool. Sandy, let's continue. Sandy. Sandy. Yeah, your screen, let's continue. At least if I do with you. I just want to make sure one person's own work and we can move on. Yeah, you've gotten the new code, yeah? You've gotten the one I gave you. Oh yeah, now compile it. Maximize so that we can see your Visual Studio clearly. I left the meeting here.
Sorry, my PC just went off. I'm about to get it back on now.
Oh, it went off like battery died.
Yeah, the thing wasn't charging. I thought it was actually.
Okay, at least you have power. Okay, cool.
Yeah,
I'm going to wait. We're very few today. What happened to Jethro, Emerson? Oh. Takes forever to come on. I'm on the bus. Up to now, Sandy.
Okay, I'm about to join now.
Okay. Christiana, why do you always not have battery for the class? Is it wrong? Is it that you don't calculate, or I don't understand? You you always say your system's about to die, even if it's if yeah.
That's, I'm sorry, it's not like that. Like I charged it. Where I stay is Kudende in Kaduna. We don't usually have light. So when I charged it, I was like trying to fix the errors because I charged it specifically for the class. So when I was trying to fix the errors, it wasn't working. And I decided to save that small battery for this morning. We've not had light since yesterday. And Kudende, there's no light in this place. That's just the truth. And to leave here to go anywhere is quite far. Like where I stay is quite far from most places that there's light. So most times I really need to calculate a lot before I go out. So that's the major challenge I'm having. So while I stayed up all night to try to fix the error, I couldn't get it. So I decided to close the laptop. The remaining battery, that was what I was using this morning when we joined the call. So it's not like it's intentional, sir. Honestly, it's not. I'm so
Okay.
sorry.
Okay. So Sandy, I'm still waiting for you. We've wasted enough time this morning. I thought by now I would have seen multiple. Sandy.
Yeah.
Okay. Good. Okay. Okay. Enlarge the screen and compile. Yeah, don't worry. Don't worry. Don't worry. Don't worry. Where's the one you got now? Just change it to 0.20. Go back up. The Pragma is the Pragma version. Change it to 0.20 and you're good. Okay. Mm, good. So it has compiled successfully. So run your test, MPX Hardhat test. Okay. Okay. What happened? Yeah. John, like what as well. Okay. So yes, there are a lot of errors. Everything. I think it just resets the right. Why is it testing the lock contract? Is it my eye? Yes, it's testing the lock contract. It's not testing. It's not testing your. Let's see your stick.ts. Okay, the giveaway dot. Okay, I'm using GS. Okay, let's see that. Let's see the giveaway.js. Okay, so walk me through it. Okay. There's no, I cannot see the asynchronous function. I cannot see the asynchronous function. So there's an asynchronous function that holds a snapshot of the deployed contract state. You're missing that. Mm. So you're missing that. So okay, nobody did his assignment, noted. So I'm going to walk you guys through it again. I'm going to walk you guys through what I did yesterday again, and that will be it. I'm going back there again. But honestly, I'm not happy. I'm not happy at all. I am not happy. So thank you. I will take over from here.
Mm.
I'm not happy. I'm not happy. I'm not happy. You guys are lackadaisical towards doing assignment and stuff, and it's not sweet. I come here every day. I show up. I do what I'm supposed to do. I give you tasks to do. And I'm happy. Okay. So yesterday we had a simple giveaway contract. Everyone had that. It pains me that you all have access to this contract and the tests are written. So I don't even understand. I'm not going to go through the contract again. What I'm going to do is I'm going to go through the test. I need this. I need this line here. I need this time. Look fixture. So, like I said, load fixture. We import load fixture from the Nomic Foundation. We use load fixture to hold the snapshot of the contract. We use expect to run our expects. This expect. There's no expect from chai. We'll not be able to check for similarities and power just went out where I am. Okay. So like I said, Hardhat gives us access to 20 addresses, just like the way Remix does. Remix gives access to our addresses already pre-funded with 100 bits. Hardhat gives 20 addresses pre-funded with 10,000 bits each. And what we do in this line, we get the signers. Anytime you call on HRA.get, it says signers, it gets all 20 accounts. It returns an array of 20 accounts, and here we're just pulling out two. If you do JavaScript and TypeScript well, you understand the concept of the structure. We're just taking out two of those addresses. So now we create an instance of the contract giveaway. Then we deploy the instance of the contract. If there are arguments, we put the argument in, put an argument in com. Put an argument in, sorry, give me a minute. Okay, I'm back. Guys. So you create, first thing first, you create a contract instance, and mind you, this is inside an asynchronous function. This asynchronous function has a name. The deploy function. You can name it deploy, then you can put the name of the contract. You get me? You guys are following? Are you guys following? Oh, good. So inside an asynchronous function with a name, because most of the functions here are anonymous, they have no names, but this asynchronous function has a name, just one of it, and it holds the deployment state. I'm not going. It holds the deployment state. For every test case you write inside the main describe, the first thing you have to have is an asynchronous function that will have the deployment state. What happens in that place is you destructure your addresses out of get signers. You create the contract instance. Remind you, this place is going to hold the contract name. So in our case, the contract name is giveaway. If not, if you tell you cannot find what to put there. Then you deploy the contract with the constructor arguments in the parentheses. If the constructor have no argument, you just deploy it empty like this. But since our constructor, see, it's going to tell you that it expects an argument. See, expected an argument but got 0. If you give it multiple arguments, what you're saying. If I give it multiple arguments, it should throw an error. So good. It's going to tell you. Okay. It's not saying, but it's just one argument. And when you've deployed the contract, you have the contract state here now. This is now a representation of the contract, and functions are methods in the contract. So you return them so that anytime you call this function, it gives you these 3 values. So you see, we're returning owner, other account, and the contract itself, contract instance created. So for us to test, each test case is defined in a describe. So our first test is we're testing for deployment. So the describe takes 2 arguments. One is a string defining what's happening in the function body, and an anonymous function. That's a function with no name. So inside the function with no name, we now use our it for each unit test. So the it represents each test case. If you notice, the first test is it should set the correct name, it should set the correct symbol, it should set the correct owner. Because the giveaway contract is an AR-security contract, and AR-security contract has the name, the symbol, the owner, it has the balance of, transfer from, transfer, made, born, it has the approval, it has the approved, it has multiple functions. Well, I think these are the 3 unique view functions that you can use to test. So because remember we pass it in here. See, this is the name, this is the symbol, and the owner. So these are the 3 things we had control of during deployment. So we test for each to ensure that deployment was successful. So good. So if you set the correct name, it takes 2 arguments just like we described. It takes the description as 1, but unlike we described, it doesn't take a normal function. It takes an anonymous asynchronous function because it has to wait for transactions to be executed. It has to wait for those results can query the result data and compare. So this line, as usual, every time before you start the test, you have to get the variables you need for the test. Remember, in this deploy giveaway contract, this is the deploy giveaway contract. Someone raising his hand. Yes. Hi, Tech.
Yeah. Your audio is not so clear, so I don't know. But maybe it's the network, so it's kind of cracking.
Oh, okay, so let me try and speak to it better.
Okay, and this is very much better.
Okay, it improved.
Yes, it did.
Okay, my mic was a little bit far from me, so.
Oh, okay.
So let me adjust.
So it makes sense. Sorry
Am I better now? No,
yeah.
It's okay. I'm clear now. Okay.
Very clear. Makes sense.
Thank you very much. Yeah. So for every test case, we return this is all we return from the snapshot of the contract deployment, the contract state itself, and 2 signers. So for each test case, we always have to get 1 or more of these variables. So to check for the contract name, I think we just need the contract itself. So we call the contract using the load fixture. We load the contract. This is the contract here. We're loading it using this. We imported this guy from the Nomic Foundation Hardhat toolbox. So this is a method that helps us to load. Are we together? Someone say something for together. Oh, okay. I see how it comes up. Good. So now this is what we're doing now. I want you to not forget this expect and stuff. This is what we're trying to do while we're going to the contract. this is us assessing this function from the contract, the name. So giveaway is the contract dot name. You remember yesterday I said you can access contracts the way we manipulate struct in the test. So the contract becomes like a struct and the, or you can call it an object, and the functions within it are like methods, especially the external, the public. So the external, the public, and yes, just the external and the public function is what we have access to. We will not have access to private functions and internal functions. We cannot call them in a test. Note that we only have access to public and external functions during testing, because those two functions can be called from outside of a contract. Internal functions are only available to functions within the functions. Internal functions can only be called within a contract and its children, that is contract inheriting that contract. So it cannot be accessed from outside, it can only be accessed from within. Private functions can only be accessed from within a contract. It cannot externally. So sometimes if you are trying to test and you're calling on a private and an internal function in your test, it's going to tell you that method not found or function not found. Good. So now this is us calling giveaway.name, and we're expecting the name to be equal to FITech, because in the constructor, that's what we set FITech. Are we together, guys? Are you guys making emojis?
Yes, sir.
Okay, good. So now, since we are here, we've gotten the name. I can even go for that to do something like this, so that I'll not confuse you. So that let me do something. Let's say const name from contract should be equal to this guy. So we can expect name from contract to equal FITech. And if I test this case, remember you can test only a case by doing dot only. So that way, if I do npx hard test and you run it, yeah, see, it's passing. It should set the name and it's passed. Do you understand what happened now? Hey guys, saying thumbs up. Oh, okay, good. So yes, so it's nothing. Let me not be bulking you guys. I can still rename this to. Remember, these are synchronous functions. Symbol from contract. Symbol from contract is equal to this guy, and you can expect symbol from contract to be equal to this. Sorry. And you can name. I can name this. I can name this owner from contract. Owner from contract. And it's an asynchronous. It awaits. Then you can try. You can do it like this. And if we test only the deployment, these three tests should pass. So testing is simple. Testing is you pulling information from your contract and measuring it against what you know it's supposed to be. Like if you set your name as John in the contract, if you want to test, you call the results from your contract and you make sure John in the contract is equal to John. Are you guys together? Someone should say yes. Let me know you're together. I don't see
Yeah.
Yes, sir.
So
okay, cool.
I don't know, based on
So
my
I'm listening to you.
based on my understanding, I think is this similar to error handling in JavaScript?
Yes. It's like catch and throw error, yeah?
Yeah.
Yeah, it's error handling, yes. Will I say it's similar? Not really, but they are in the same group chat. This is just that making sure your code is working perfectly. You
Okay.
understand?
Yeah.
Before you go ahead. So you see now we've tested deployments. So the next thing we can test the function root the participate function. So I close my describe block. I'm done testing the deployment. I'm satisfied that the contract was deployed successfully. Then you can create another describe block. You name it the participate function. Name it you give it the description is participate. Then it takes an anonymous function and thus you can start putting in your first test case. So since it's a giveaway, the first thing you should test is that the people that participated in the giveaway received their funds. And again, probably all these things are confusing, so I'm going to be abstracting them. I'm going to be breaking them down for you so that you understand. So here now, we are getting costs, users balance the contract equals to this. So you see, well, let's read it together. We are awaiting giveaway, that's the contract, the balance of the user, the guy that participated. Do you understand that? Then the second thing is, I think I can use const. It's reward amount. Reward amount from. No, I'm going to use long descriptive names because I don't want to have. So this reward amount from contract. So yes. So we are checking to be sure that users balance is equal to the reward amount from contract. So you guys, I hope now it's clear.
Yeah.
It's clearer than I'm making it clear now, but
Yes, sir.
good. So if we test it now, dot only around only that test supposed to still pass. Good, it passes. So the users, so what this is telling you is that the user's balance increases. But if you want, where is it? I can do this. I can do this before the users before this guy participates. I can query his balance before. That's before. And I can console.log it. Log users. Where is it? Interesting. Name. Something like this. Let's put a comma. Yes, users balance before. Yes, then and so that you can see the difference. And after he participates, you can query his balance after and console it. Business balance from contract. So I am opening this too. So that you understand, so that it's not abstract and you understand, you don't think the test is even. Good. So you see, his balance before he participated in the giveaway was what? 0. And after the giveaway, you guys see the balance increase. Are we together?
Yes,
And
sir. That's
so you
good.
guys are understanding what's happening. Hope nobody's
Yes.
lost. If you are lost, speak now so that I know. Good. So where am I? So our next test is it should deduct from the price pool. So good. I like the way I did this. Yes. So now if you console, this is the price pool after. Let's do it like this. Price. So let's this price pool after. This is the price pool after. Then let's check the price pool before. This is the price pool before. It's here. The price pool before. So in essence, what you are testing is this place down, the price pool before nothing has happened. This is the place where something happened. This is where something happened. This is where the user called the participants. Await giveaway or connect on account of participate. This is the line where the user participates. So we're comparing the information before he participated and after he participated. So if I bring my dot only, and we check it out, test it. So you see, before the giveaway, the price pool was 100,000. After the giveaway, the price pool is now 90K. Hope you're understanding.
Yes, sir.
Hope we're together.
We are together.
Okay. So I think I've explained that, and I'm still not going to. So I'm still not going to do the rest. I was thinking about completing the code. So the assignment still stands. Our next class is on Monday, and by so help me God, people did not finish it. We'll not do that Monday class. So everybody that doesn't have lights now, look for lights for Monday. I'm accessible. You can reach me out. You can reach out to me, and I'll put you through. Are you getting me? I can help you if I have the time to. But one good skill of
Thank you,
developer
sir.
is for you to be able to read people's code and be able to create solutions from it. You can see what people do. If you can mirror someone's work, then you're already a good developer. Like you're already 70% good. Your ability to read, comprehend, and do something else with someone's code will say a lot about you. So I think I'm going to draw the curtains for this here. So we're supposed to go into upgradable contracts today, but I don't think you guys are ready for upgradable contracts at all. So I'm going to introduce you guys to another framework, because if we want to do upgradable contracts, we will need to combine Hardhat and Foundry. And well, I think I've done my due diligence with Hardhat. If you have any confusion on Hardhat, you can refer to our videos. So now I'm going to introduce you to Foundry. So this Foundry, and Foundry too. Foundry is another framework, just like Hardhat. But Hardhat uses JavaScript and TypeScript, while in Foundry everything is handled in Solidity, from writing of tests to writing of script. So you need to install Foundry. Where's the good Foundry book? I'm going to drop the link to the Foundry book. You should keep it where you can get access to it. You should keep it where you can get access to it. This link. Oh, Christina, can you hear me now? I saw the audio is not clear.
Yes, sir. Can hear you now.
Okay. Sorry. So good. I've dropped a link to the Foundry book. So yes, you can come here. You can come to installations. It will walk you through on how to install Foundry. I think it's not hard. It's just to do Foundry up. Okay. For those of you using Linux, I think you can just come copy it here and you install it. Yes. So I don't think we'll have enough time. If you want to use Docker, I think for those using Mac also, there is Docker. For those guys using Windows, I don't even know. Okay. For Windows users, you also need a recent version of VS Code to the desktop. Okay. So I think we'll go straight to creating a new project. Since you have 3 days, you can figure it out. I'll share the link to a book. So anytime you come and you want to create a Foundry project, you go to the directory you want to create it. So if I say I want to create it here, I can come to FiTech. Where am I in your folder? Yeah. So I can just right click, open it in terminal. Then okay, always be making reference to it. So that's the forge init head of Foundry, copying forge init head of Foundry, and I press enter. Oh wow. Coming. Foundry up. Why is it not seeing it? Okay, let me install it again. So good now. Maybe you guys will see the installation then. Installation. Because I know if you type Foundry up, it's supposed to be upcoming. Foundry up like this. Okay. Foundry. Foundry up. Yes, Foundry up is supposed to install Foundry. Yes. So it will take a minute, but let's see. That's 9:14. Okay, I'm waiting for the installation to be complete. It's at 86%, now 87, 89, 90, 92, 99, and it's complete. So, where are you guys? You guys saw the way I installed it, right? Foundry up for Linux users. Foundry up is the command. Beyond. Yeah. So good. Everything is done. So for you to initialize a new project, the way we do npx Hardhat dash seed dev dash. This one you just do forge seed forge initialize forge init, then the name of the folder. Let's use hello world. Okay, something is wrong here. Forge dash showing up. Yeah. Oh, no, okay. I'm good. Okay. I'm having issues. I'm coming, sorry. Forge init. Okay. ls make make directory FiTech cd FiTech forge init. Okay, good. So what I did now was I was trying to create it all in one line, but it's not work. It didn't work. So what I did was I created a folder. This make directory. I created a folder. So you could just right click create a folder. I entered the folder. Get. Then I installed Foundry in it. So if I list it, I should see VS Code. I've seen Foundry.toml. Okay, let me open it in VS Code now so that I see what it looks like. Before it opens in VS Code, did I leave anyone? Was anyone confused with what happened there? I was confused with what I just did. Raise your hand up or a reaction so that I can go through it again. I understand and I'm good. Reaction. Christina, which of it? Which is it? I should do it again, or you understand?
Yes, I'll do it again.
Okay. Like being quiet. Okay, good. So let me do it a simpler way. So if you want to initialize a Foundry project, you just create a new folder. What's the name? Which name should I call it? Phytech Foundry. Yes. Sorry, let me close this. Yeah. So this is Phytech Foundry. You know, you can open it in. We can open it with VS Code. Yeah. Let me do it. Bari, like some people be saying. So yeah, I see Johnson just joined. So Johnson, Yaomi, yeah, you haven't missed much. So I've created, this is an empty directory. As you can see, it's an empty folder. There's nothing in it. So I'll just open my terminal, open the terminal, and I'll do forge. I'll do around forge init, press enter, and voila, I've made it a Foundry project once it finishes. So you see, I've made it a Foundry project. You notice that GitHub is released, leave, forge std, scripts, source, test, and so on. So for the source, this is just a simple it's just a simple counter program. It's a simple counter. It's set number. This is Solidity. Hope you guys know that. There's no magic. This is the same Solidity, right? In Remix, yeah. And I advise you use Hardhat. Hardhat is, I say Hardhat. I advise you use Foundry. Foundry, it's not that hard. It's very straightforward to use. So, okay, I think we should bring our giveaway contract here. You're laughing. Hardhat is, Foundry is simple. Hardhat is a little bit more complex than Foundry. And almost everybody is good to know how to use both frameworks too. So, I think I need to go to Discord and get something. I'll drop it for you guys in the chat bar. So let me see. Yeah. Yeah. Some things that I've forgotten. I've forgotten something I'm supposed to show you guys, but the joy is everything is out there. Okay. If you skip, you can always ask the internet. The internet always helps you remember. Because we install OpenZeppelin differently in Foundry. So this giveaway.so. We don't need to do get asset again. This giveaway.so. Yes, copy it. That's all I'm working on. Then I can just come. Let's leave counter alone. Let me do giveaway.so. Giveaway.so like this. And let me paste giveaway.so here. Good, it's complaining about OpenZeppelin. Let me remember how. So I can just come to the internet and ask the internet. installing OpenZeppelin. Yes, Foundry. I think it's, yeah, it is. I think it's the same way. Let it come up. Yes, using Foundry. Installation, because in Foundry it's different. So that's in yesterday. I left my charger there. Um, so good. So once you come here, you can let me drop the link for you guys. Okay. Good. So what you install? Okay, yes, we just copy all. One here. Copy all. Yes. So just come here and paste it. Oh, what's it saying? What's it saying? Okay. Dash no dash commit item. Good. You just add the dash no commit flag. That's what I did. I added dash no commit to what I copied. And it's going to install OpenZeppelin now. Don't forget, I'm going to restate it again. Don't forget to add dash no commit. Is my voice good? Are you guys hearing me? Okay.
Yes, no.
Okay. So yes, so I'm coming. Looking for something. Looking for something else. Installed OpenZeppelin. We need to import it correctly. Okay, still installing. Because this import is not working. I think it's installed unlike in Hardhat where we install it the way it is in the OpenZeppelin is that here we will edit the location because it's not stored in it's stored in the lib, not Windows. Okay. Let me finish installing. Upgradable. Okay. Wait a minute. Then install the correct one. Calling. Second line. Oh, okay, I'll use this one too. Okay, let me see if it's on work. Because this is the one I know. When the set is already installed, then there's no need. Because this guy is not having what I'm looking for. Okay, that's contracts. Okay, pass it. Okay, so thank you. So we're going to go to F2 from lib. Going to get it from LIB. Oh, okay. Sorry, I'm coming. A lot of work here. Import ERC20 and the comments this line out. ERC20. So comment this line out too. Or from it should be from lib. It's saying counter.so from counter.so. Sorry. Let me get this thing from somewhere so I don't need to stress myself. Are you guys still with me? Let me see reactions, please.
Last week, sir.
Okay, good. I'm trying to get something open. All right, if you go and look for this record, you don't see it. Though. See, there's bad luck on it. Okay, yes, I have my bank.so. So, that's what I was trying to do. Water and transit guard, yes. Good. But from the yes, so okay, I was correct. It opens the plane, okay, from the opens the plane content. Okay, opens the plane contract, yeah. Interesting. Interview. Okay. And enable. Only. Let me do like this. Yes. So, okay. Let me remove this, what I installed last. Okay. I'm going npm install. Because I think I'm installing a newer version. That's why it's giving me the setup. I'll check my dependencies. My goodness. OpenZeppelin. I'm going to push this, so don't worry. So let's this finish. It's not upgradable sound to install. I think I'm not using the right installation code now. Yes, this is yeah. This is the code. Don't worry, I'll tell you guys what's happening in a minute. Yes, let me remove the one I put. Yes, good. I've removed it. So this is the correct installation code I was supposed to use. I was using the wrong one then. Dash dash, then you add the flag, dash dash, no dash, commit. So I'm going to drop this guy in. So drop this guy. Let me be sure it's this guy, then I'll drop him in the drop it in the chat. Because even though they work closely, like they do almost the same thing, installation happens differently on both of them. So by the time I introduce you to Foundry, so I would like you to take the 3 days that we have and acquaint yourself very much with Foundry, because as on Monday, our class is going to be upgradable contract, and Foundry is what we are going to be working on. So yeah, that's why I see the need of introducing you to Foundry today. So we won't come and be looking confused on Monday. But so now you say it's correct. When you go to lead, we have OpenZeppelin that cash contract. OpenZeppelin dash contract. Why is this guy not? Okay. So you see, that's kept bytes here. And this one now should keep bytes too. I have structure too. So good. So did I drop the code in the chat to install OpenZeppelin? Yes. No, I didn't. So let me drop it for you guys so that you guys can have it easy. So yes, this is the code, and this is the import logic. You're going to see that in the when I push it to GitHub. So good. So forge install. This is how you install OpenZeppelin in Foundry. Can I just get a little reactions to know that what together? Okay, nice one, Sandy. Let's see. So okay, so we've written our contract and it's not throwing any errors. We hope it doesn't. We know it shouldn't because we had worked with it already. So the way we can compile our contract in Hardhat, we use npx Hardhat compile. Here we use forge build. That's what we do. So now forge build compiles it's going to compile our contract now. And see, compile run successfully. So don't forget to use forge build to compile. To compile, use forge build like this. To test we use forge test. So remember we haven't written any test, but just like in Hardhat, everything comes with its own test, comes with the default test, and they have written their own test for this counter contract, and by the time we run forge test, like like this, and we press enter, so see, it has run the test pass and to fill. So we can make it there's something they call verbosity. We can make it dash v V. Verbosity, you can have verbosity up to 5. So what this does is it gives you in detailed information about your test. So in case a test is failing and you query it with this verbosity, it lists out your errors. It tells you that this is so and so place that it's failing. So let me press enter so that I can see how this works. So now remember the first time it just shows us run 2 tests and 2 pass. So now good. So now you see it takes you through the whole test process. So you see it ran the setup, then it returned the fund, it returned something, then it sets the number to 0, then it stops. So you see how the test is being explained. Are we together? I need reactions to know what together, please.
Yes, sir.
Okay, nice. So what we're going to do now, very snappy, we're going to write our own tests. So I'm going to create a new file, which will be gives away dot sol. So unlike in Hardhat that the tests are written in JavaScript or TypeScript based on what you're using. So this one is written in TypeScript. So I think I'll take the first 4. I'll take the first 4. These guys, you think we always need them. Let me paste them here. Yes. As usual, the SPDX license identifier, the Solidity version for the test. Then we import test and console for the STD. So now, in this case, your test is a contract. So I think those of you that don't like JavaScript or TypeScript will really enjoy this one. So our test there is a contract. So we should name it giveaway test. Giveaway tests. So it is test. So inheriting test. Then, so the first thing we do is we create a contract instance. Just like the way we had that. And it's the name of the contract. Okay, good. We have to import our contract. So our contract is what we're importing. Import our contract. Our contract is titled giveaway. Giveaway, and we're getting it from dot backslash source because it's in another folder. Source slash it's giveaway not in the clause. Give away dot so why is it crying? What's up? Yeah, good. So we imported it correctly. So the contract instance is going to be of a type giveaway. Going to give away and we'll call it public. I'll make it give away. So this is creating a contract instance here. And so the setup will mix deployment. There you go. Function. This function here. The setup. Okay. Function setup is deployment. Are we together? So we run the function. This sets up like this. If you don't name it like this, it's not going to run unique deployment. You make it a public function, and it's like this. So you now do giveaway. Someone is raising their hands or something. Okay, yes. Landing. Yeah. What's it? Tally Nanzing. Your answer of what's it? Okay, I'll interpret that as a mistake and continue.
Please, I've dropped attendance link on the comment section. Please go and fill the attendance.
Go and fill attendance. People that came late to class.
I said I dropped attendance link.
Keep quiet. Stop interrupting me. So good. Giveaway is equals to new giveaway. So so what we're doing here now is we are specifying. Okay, what's wrong? It's not implicitly to expect. Okay, there's an error. Okay, yeah, because to give you I didn't call it. Call it. So, yes, type becomes it's not implicit. Okay. I function address. Okay, giveaway. When we deploy giveaway, we deploy giveaway with an address. And how do we do that? We make an address. Yes, to be referring to something else because we have to make an address. Now I remember we need to make an address. Let me pick the syntax of making an address. It's entire. Sorry, I'm referring to my old work. Yes, let me use this. Yes. Okay, so just I'm gonna make an address like this. Mhm. Okay, because we need to deploy the contract. Remember, we deploy the contract has fixed an initial owner in the constructor. So good. So and make an address. So I have player one and player two. So the owner, like the owner of player one. Supposed to deploy it now. Okay, counts for function cover arguments. Good. Yeah. Please, do you guys understand what I did? Or I should reiterate myself?
Please go over it again.
Okay, good. I'll start again. So you understand the contract. I've explained the contract yesterday. You understand the contract, yes?
Yes, yes, sir.
Good. So now what I'm doing now is I'm writing a test for the contract in Foundry. You know, yesterday we used Hardhat. So I created a new folder in the test. I created a new file in the test folder. Can you say? So Foundry writes test using Solidity. The SPDX license identifier is a constant for every Solidity contract. You know that. The version is there. I can change the version to match uh, this, to match the contract version if that's what we want. So you need to import tests. You don't always need console, but you need to import tests. So you import tests. Then, sorry, give me a minute. Hey guys, I'm back. Okay. So as I was saying, you import test. So you see these three lines, this 1, 3, and 4. You always import them. You can just copy them and paste them. So I import the contract I want to test. This is the contract I want to test. This is it. This is the contract I want to test. The contract name is giveaway and it's located at this location. You understand? So I create a contract. This contract is a test contract. You can name it whatever you want, but make sure it inherits test. So I create a contract instance. That's what I did there. So here, in Hardhat we get signers. Here we create accounts. So this I create 2 accounts. That's player 1 and 2. Player 1 and the 2. I created them myself. So you see, I just said address player 1 is supposed to address OXA. Can name this anything. Get just our OX. Can name it OX1, OX player 1. Anything you want to name it, you can name it. You get me? Why is it straight arrow again? So okay, P is not hexadecimal. Yes. Hexadecimal is from 0 to F, just like their addresses is. So it has to be numbers between 0 and F. Yes. H. So good. So are you with me, Christina? You know that
Yes,
asked
sir.
for. Do I need to re-explain or you understand so far?
Yes, sir.
I understand, sir.
Okay, good. So now, what happens in the function setup is if this is where we deploy a contract in the function setup. This is where we deploy the contract. So this function is going to be run before every test case. So anything you save here is final. So remember, in our giveaway contracts, we deploy it. The constructor takes one argument, which is the owner of the ERC20 token. Are you what together? Yeah, that's the owner of the ERC20 token. So that's why I'm deploying it with player one as the owner of token. So if we want, I think if we want, so now this giveaway mimics how will I put it? It mimics a contract just like the way it did in that Hardhat place, and you can do giveaway dot this. So now we can now compare. I can now say we should assert equal that um that giveaway dot name, then you call it, because here is different, comma, it should be equal to what was the name? Fitech. Yeah. FITECH, like this, I think. And okay. So hopefully that should run. If I run forge tests, I should be successful. Okay, no, it's not running this. It's not running this guy. Let me build it then. It's not running it. Sorry. What else? Okay, it's not. Sorry. Come. Why are you not running this? Hmm? I'm not running giveaway. Okay, sorry, it's not running it. What's noise? Okay, there's no tests. There's no tests. There's no test, it's just the setup. There's no test. So now let's write a test function. I can name it test. I think it has to start with tests for it to run. Test deployment. So this is test deployment. Let's make it public. Good. So I think what's wrong? View. Okay, yeah. It's solidity. Let me see. What again? Yes, it's view. Okay, good. So you see, test giveaway. You see the name. Let me comment this test out so that there will not be conflict, so that you understand. So I can. So now, if I run this test, one test should run. My system battery also. Good. So you see, run one test for giveaway tests, giveaway one. If we do it like this, and I add velocity, that's dash VVVV. Please hope you guys are understanding why this test is passing, please. If I understand why the test is passing, let me see your hand. Just reactions. Nice, no reactions. If I don't understand, let me see reactions. Sandy, you don't understand?
Yeah, I got missing along the line.
Where did you get missing, Sandy? Let me look for you. Where did you lose? I've just written 4 lines of code.
The thing is that from the installation, I'll just go back to the video because I was trying to set it up when you were on this.
Okay. Okay. And sometimes it's cool if you just follow along and you get it before you try. You understand? So, so you see, so okay, ownership transfer. Previous owner was address 0, just transferred to OA. OA is player 1, and you see, it returned when I run giveaway.name, it returned Phytech, and when we assert Phytech to be equal to Phytech, it was correct. Just like the way we can also assert, what can we assert again? Someone should tell me that what is called to what. Someone should say something. Let me know we're following. From the last set of test periods using Hardhat.
So what did you say, please?
I said, what can we assert again from this contract to be sure it was deployed correctly? We've compared the names. Names are the same. What else can we compare? Nobody knows. Wow. Christiana.
Sir?
What can we compare again? We've compared the name.
Participate.
What else? Participate is calling a function. I asking what can we compare to make sure that the deployment was successful. Mind you, when we were deploying, that's in the constructor. You see, we set this guy, we set this guy, and we set this guy. Johnson, I see you on the call.
We can check. I think the bounty winners is no more than 2, no less than 2.
On deployment, no sir. Like you see, on deployment, we set the name of the contract, we set the symbol, we set the owner. Okay. I just checked for the name and the name match. What else can I check? Oh, look at the answer, it's looking at you.
Okay, so we can check for the symbol.
Yeah.
And what again?
And the owner, the initial owner.
And that's what we checked for in the last one. I don't know, it's the same contract, nothing new, I didn't change anything. So I'll do give away dot owner, we'll call it, it should be equal to, who should it be equal to?
FIT encapsulator.
Sir?
FIT encapsulator. The symbol is FIT encapsulator.
The owner should be equal to FIT. The owner should be FIT.
Okay, is it the owner? The owner is address now. Address.
Whose address are we putting? We have to put an address. So who are we checking?
The initial owner.
The initial owner.
Yes, who was the initial owner? I know we're checking for the initial owner. Who was he? There was an additional owner now.
Phytech, is it Phytech? No.
So initial owner is message.sender, I think so.
Initial owner will pass in an address. See, the constructor, how does constructor work? The constructor, it's a function that runs on deployment. Constructor asked us for an owner. Can you see? I highlighted it here. And I told you the setup here is what? The setup, what is this?
The setup is the deployment.
Good. So I'm guessing this line is where the deployment happened. Yes?
Yes, sir.
Yes, sir.
So according to that line, who is the owner?
The first player one.
So who are we going to whose address are we going to compare with the owner from the contract?
The player one address.
So why are we doing as if we did not go to school? Okay. So then what again are we asserting? We can assert equals. Can assert equals that give away giveaway dot symbol. Yeah,
Yes, sir.
dot symbol. Call it. And what should it be equal to?
FIT.
FIT.
FIT. So if this test passes, it means that our deployment was successful. Correct?
Yes, sir.
Correct.
So which platform will you prefer to write your test with? Would you prefer you use? So okay, one test passed. So FIT is actually FIT. The symbol, when we call the symbol, it returned FIT. So we compared FIT was FIT. So that's correct. When we call giveaway.owner, it returned this as the owner 0xa. So we compared 0xa with 0xa and it was correct. Then, so which of these platforms would you prefer to work with? Would you like to work with Hardhat or would you like to work with
I
Foundry?
think I would prefer Foundry.
Me
Why?
It's
too.
shorter. It's shorter.
I like Foundry too.
It's shorter.
I mean, I like Hardhat.
You like Hardhat?
That's why it's called Hardhat. Hard things.
Okay. So now, so we've tested for deployment. So what else can we test for now?
But I think participation or something.
Okay. So let's test for function participates. Okay, remember to put tests so that it recognizes it as a test. So let's test for participates. Okay, we need to make it public. Need to make it public or external, anyone you choose. So good. To participate now, I think what we have to do. So that's what we call chip. You remember using Hardhat, there was when we had to open a new window, when we had to connect others so that we can change the MSG.sender. Remember I told you the MSG.sender is mostly the first one. Do you remember?
Yes, sir.
Oh, it's as if I've deleted the book at that. Good. So let's go to, let me show you what I'm talking about. Deduction price pool. You should okay, participate. You see dot connect. You see this line. Await giveaway dot connect order dot participate. So in Foundry we have what we call cheat codes. So I think let me see Foundry whether cheat codes are here. Let me look for Foundry cheat code. Let me look for Foundry cheat code. Yeah, Foundry cheat code. Foundry cheat code. Yeah, cheat codes. Yeah. For testing, in Foundry testing, we have cheat codes. So cheat codes are just like codes that they are cheats. How I put it? They're just like keywords that we use that help us to perform certain actions. So we have the vm.prank. That's the one I want us to use. So what the vm.prank does is vm.prank allows you to make an address msg.center. You cannot see it here. VM. Wait, that's my guy using vm.prank, using vm.prank and found tests. Yeah, that's what we use. Yes, so it's a super handy cheat code. Yes, so good vm.prank. So now let's say we want player 2 to participate in the giveaway. Yeah. So before we call on anytime, if we call on giveaway dot participate, and we do like this, automatically it's the contract that participates, or is it the first player? But if we want a particular address to be the one to call this function, you just vm dot prank, and if we call player 2 now, if we see player 2, the message.sender automatically becomes player 2. Do we understand?
Yes, sir.
So let me put it. This line makes player 2 the msg.sender. Do you guys get that? I want to hear another voice aside from Christiana. Did you guys get that?
Yeah, fine.
Good. So now player 2 has participated. So what do we expect? We expect player 2 balance to increase, yeah?
Sir, I have a
Yes.
question.
Okay.
Yes, sir. What I want to ask is that if we're going to have like 10 players, are we going to write the test for all the 10?
Yes, that's why I had to reduce it to 3. I did reduce it to 3 towards the end of the class.
Okay, sir.
Yes, so that after the third one, we can be sure that after player 3, no one else could be able to get. You understand?
Yes, sir.
That's it. So good. So player 2 has participated. So what we can do now is we can check. We can do Uint 256. Remember now we're dealing with Solidity. It's not JavaScript again. So we'll call it player 2 balance before. That's before he participated. It should be equals to you write give away dot balance because it's an ERC20 contract balance off. Then we can put layer 2. Yeah, are we together?
Yes,
Are
sir.
we together? Yeah. Good. So that's his balance before. So after he participated, then we can do unit again 256. Layer 2 balance after. Yeah, it should be equal to this guy, to the balance when we call it after he participated. Do you guys understand this? So we can assert that the balance before is 0. Yeah?
Yeah.
We can assert that the balance after is, so let's get
10,000.
okay, we can put 10, 1, 2, 3, or we can query the remote amount and check it. You understand? Anyway, it works. So, or we can even say we can assert that the balance after is the balance before. Plus 10,000 because we don't know his balance. We can claim ignorance and say we don't know his balance before. Do you understand?
Yes, sir.
So we can say the balance after is the balance before. 9 months was the other. Let's find out that. Did anybody think? So good. So let's run the test and see whether we're doing rubbish or not. So let me run the test. Please. Okay, so our assertion failed. Good. So assertion 10,000 is not equals to 20,000. Wow. So you are seeing that. So one of our assertions failed. So it's saying we're trying to assert that 10,000 is not equal to 20,000. Okay, this is not supposed to be after. This is supposed to be balance before. You see? So it was from our end that the error happened. Are you guys in?
Yes, sir.
Okay, so everything passes. So are we good?
Yes, sir.
Do we get it now? Do we get testing in Solidity now in Foundry. So let me make this guy that only 2 people. Where's our contract level? Okay, I make it that. Okay, let's make it that only 3 people. Okay, this will make it only 2 people can take it. This 2 makes it that only 1 person can participate. So if, let's say for instance, we have a player 3. I have a player 3 now. 3, and let's give him a different address. See how easy it is to make another address, and we prank him so that it becomes the. Okay, let me. I've forgotten how to make something revert. So let's take all these ones. Yes, participate again. Let's name it differently so that guy can keep quiet. We don't need the balance of player 2. We just need to prank him, and he should participate. Let's delete everything. So that means player 2 has already won the money. Now let's now get player 3. Let's now make player 3 message.sender. So let's make player 3 and expect player 3 to participate. I think this is going to revert, but let me look for the cheat code that I can use to mimic that. Yeah, it's supposed to be a cheat code that you can expect to revert. Expect revert. These are tiny cheat codes. You can go and look for. You can go and browse the internet. But do people know why I want to expect this to revert? Because look at it now. The winners here, we have a require statement. Oh. So do we know why this is supposed to revert? Somebody look at it. The bounty, it requires less than 2 winners, and it's only 1 that is less than 2. And obviously in this case, player 1 it's going to player 2 is the winner. So in short, let me run it, let it fail so you can see.
Because winner is meant to be less than
Just
2.
one.
Anything
Yes.
more than that.
Yes. So okay, it passed though. It passed though. It did pass. It did pass. It did pass. So what did we do wrong? So what did we do wrong? Did we increment the winners? Did we increment the winners? Winners. So we just said winner. We didn't increment it. So we didn't increment it. So we can do winners plus at the end of everything. We should increase the number of winners. So you guys see, like the way testing helps us to repair our code. Remember yesterday now? I think I'm using. Do you guys understand what just happened?
Yes, sir.
Let's see.
So, but sir, but why did he even pass in the first place? Because
Wait,
we already wrote.
Wait, it's still passing. Passing. Why is it passing? It's still passing. I'm coming. Let me look for it. This is the first participate. Okay, and this guy has reduced to 80,000. That's the paid to people. Why is it still passing? Winners plus. Required our winners. So, come. Let me try again. It's not supposed to pass. If it passes, we're dealing with serious bug in our code. Okay, I think I know why it's passing. I don't think. Okay, it's compiling. Okay. Good. Okay, bounty have been exhausted. When does it revert? Bounty has been exhausted. Okay, it's now that it's reverting. Bounties have been exhausted. Bounty have been exhausted. You see now it tells you bounty has been exhausted. Or why? Why is it the 3rd time? Okay, yes. So the first person collected, the second person collected. Are we together? Let me
Yes,
create a player.
Yes, sir.
Let me create a player 4. so that we can understand what's happening in this should be player 4. So we should have VM.bank player 4. Player 4 should participate. So that means player 1 and player 2 collected. But why is this thing not? I'm not comfortable with it. Let's build it. Okay. This is supposed to fail. It's supposed to fail at player 3. It's supposed to fail at player 3, not player 4. It's supposed to fail at player 3. It's supposed to fail at player 3, not player 4. Oh, learning build watch test. It's supposed to fail at player 3, not player 4. Good. So let's see. So participate again. So player 1 participated. That's address A1. Address C1 is address D that didn't win. Storage changes 1 to 2. Okay, I understand. Okay, now I understand. In the first, when it happened here, winners was 0. You understand? So after player 2 won, winners became 1. So it allowed player 3 to be able to win. Do you understand? It's 0 base. It didn't start from 1. Do you understand why it's allowing it? So so this place is not actually 2, it's 3 because it's 0, 1, 2. Do you guys get?
Yes, sir.
We understand that now.
Yes, sir.
I forget something else to do. I forget chapter here is to do. In mouse or no, it's not necessary. Okay. So now, if I uncomment this line, then if I uncomment this line to expect a revert, then it should pass because I did VM. So do we understand this now? Do we understand this now? So
Yes, sir.
good. So now I'm going to show you how to deploy using Foundry. It's the simplest thing ever. In short, you deploy and verify on one go. I think I have it somewhere. I just wrote it and kept. Yes, good. So I'm going to explain it. Yeah, this private key, people like if you copy this private key and steal this Sepolia that is there, no problem. If my Sepolia lost, someone people hear it. So to deploy on Foundry, you just need this special cheat code. I'm going to drop it for you, so don't worry. You get me? I'm going to drop it on the call. So I'm going to walk you through it. It looks very long and bulky and tedious. So now the first thing first is you are going to do forge. You see, let me increase the size so that you can see it well. So you see, we'll start with forge create. So now forge create contract. So you write the name of the contract. That's what you do. So now we write the name of the contract. That's the file. That's what I write here. That's what you're supposed to write here. So the file is in contract slash and give away. It's giveaway.sol. So then the next thing is the name of the contract, and the name of the contract is giveaway. Away. Are we together? Are you guys
Yes,
following
sir.
me?
Yes, sir.
Then dash broadcast dash. This is for the verification. You do dash. You now API Etherscan API key. Then you put your API key. This is my API key. Are you getting me?
Yes, sir.
Then dash verify. That's to verify the contract. Then you put dash RPC URL. You remember the remote procedure call spoke about yesterday? Then you paste in your RPC URL. Yeah, I'm going to change this code because this is personal to me. So I'll just you can clean it and put your own. Then we have the dash dash private key. After the dash dash private key, from this 6 is me pasting my private key. Are you getting me? This is me pasting my private key. Then the constructor argument. Good. The constructor argument is 2, but it's just 1 in this case. For this contract I deployed, it was 2. Is the owner's address, and I think this is the address to one of my contracts. So I put that in, and let me delete this second argument. Good. I don't need this second argument. So once you just write this like this, instead of you creating a script and writing all the JavaScript code like we were doing in Hardhat, this is just what you need to deploy a contract. You just press enter, and that contract should be deployed. So I think it should. Okay, good. Okay, no such file or directly. OS error. Okay, sorry. Let me see. Okay, no slash. Okay, I understand. Its contract is supposed to be source SRCS. Intel Foundry. This is supposed to be SRC, not contracts. I was making it from a different place. So this is supposed to be SRC. Good. So in one line, just with this piece of code, Foundry will help you deploy and verify your contract. So I'm going to drop this in the chat. You can keep it very close to you. Instead of you struggling to deploy, you just edit this contract, and that's all. So good. See, it has deployed it. See, it has deployed it to this address. Now it's submitting it for verification. So it's going to go on and go on. Don't worry, it will get it, and yeah, it will get it because it's network and testnet is a little bit so good. Okay, so it's pending in queue, verification is pending, wait 15 seconds before trying again. So it's going to try it for, I think, 15 times 7, 5 times 7 is 5 carry 3. It's going to try it for almost 2 minutes. And good, contracts are successfully verified. So if we go to this link, you see the contract we just deployed. You see the contract we just deployed, and it has been verified and successful. So Hardhat or Foundry, guys, which one would you pick?
Foundry.
There was someone that said he loved Hardhat. How far have you changed your mind, or you're still with Foundry? Is he still on the call?
Sir, it's Johnson. I don't think he's still on the call.
Okay. So what do you think about this? Let me construct arguments. Put construct arguments. Okay. Wait, let me write this clearly. I need to write this clearly so that I can edit it. So, and that's all. That's how you deploy a contract using Foundry. So let me make it easy to read so that I can share it with you. So okay, forge, create, source. This is this is the what do you call it? Why is this thing? Why did it comment this guy out? Go back outside here. Yes. And comment, sorry. Let me pick what I picked. I don't want confusion. Confusion for you guys. It's gonna be something. Yeah. Message. Okay. I think I'm good. Sorry, I'm having issues here. Like one big. Yeah. So this thing is correct. Yes. So yes, you just put So do I need to explain this? You put your construct argument here, your private key. After everything, you just put what's supposed to be there. Are you guys, do you understand, yeah? Are you guys understanding me?
Yes, sir.
So I think it's not supposed to be hard. So this will just help you locate this is the part, the file. So good. So yes. So just edit it. At least let me know if it's spoon feed you all the work. Where are we? We're supposed to be in this folder here. And yeah, come here and let me paste it for you here. So that's it. Forge create, giveaway dash dash broadcast, then dash dash. You put your Task API key here. Dash dash verify. You don't put anything. Then dash dash RPC URL. You put in your RPC URL after that. You dash dash private key. You put private key here. Then dash dash constructor arguments. And in this folder, the constructor argument is what do we call it? Is owner. You can put your address or not. So I've covered testing and deployment in both Hardhat and Foundry. And I think if you have any question, it's time to ask it now or forever with your piece. So I'm taking questions now. Guys, I'm taking questions. If there's no question, okay, adios, Namutia.
So for deploying,
Yes.
okay, we will have to use that command on the command line, right?
Yes,
So
yes,
it's
on the command line.
okay. It's not like the other one that we have to pass it as an environment variable.
Yes, exactly. So just pass it on the command line. So it's easier, yeah?
Yeah, it's more shorter than
Yes,
other.
and you deploy and verify in one line of code. So you see there's no much stress.
That's great.
Okay, so I'm going to push again, and I want you guys to complete. Now, I want you guys to complete the whole testing process for it. Is that okay? And for fun, I want you guys to complete the Hardhat test and the Foundry test. On Monday, I will call at random, and I might call you and tell you to present your Hardhat or your Foundry, so you would know which one you're presenting. And I'm taking notes. I'm taking a screenshot of everyone that's in the class, so that all of you that I was not in class do not happen again. Are we together? So I know you're seeing my screen. Let me screenshot the class. So everybody that is to say I was not around, my network is good. I've screenshotted everybody that's in class today. So no question, yeah?
No question.
Good. So we're supposed to go into upgradable contracts today, but you guys failed to do your assignment and we couldn't touch in on that. But I'm going to touch in on that now. I think I'm going to touch in on that. So coming CD, let me push this to GitHub. So it's going to be in the same repo. You're going to notice two folders. One is Hardhat, adding embedded. Okay. Fix it. Yes. It's result. I'm trying to do something. Okay. So let me just rename this so that it will be easy for you. Fintech Foundry. So yeah, good. So let me add it. LS. I'm coming. Oh, what have I done? Into H. Oh, that's okay. But paste it here. Paste it here. Okay, control H. No longer there. The country. Okay, let's add. Okay, it's commit dash it's a feature foundry update foundry. Okay, push it, git push. Good, so let me paste the link for you in the chat. So okay. No. Can I delete this? You don't need the dot kits at the end. Like don't need the dot kits, like it's just this. Okay, so let's talk about upgradable contracts. For the next 30 minutes before our time expires today. So once a contract is deployed, can it be mutated? Can it be changed? We're having an interactive class, please.
According to the explanation we've had in the past, it cannot be changed after deployment. That's
what they told you about.
Yes.
Yes.
Because the blockchain is big on mutability. When it says it's immutable, like I remember multiple definitions of the blockchain. It tells you that it's distributed, immutable digital ledger. Yes. This should be answering now.
Yes, sir.
Yes, sir.
It cannot be altered after deployment. Nice one, Joel Hapila. Yes. And yes. So people cannot change what they have on the blockchain. It's true. But you remember in primary school now, when we were in primary 1, primary 2, when we were doing maths, that time they tell you 2 minus 4. What's the answer? In primary school, no? Someone should help me now.
2 now.
Sammy, I cannot remember my primary school days.
2 minus 4. If you
Boys
tell
minus 2.
In primary 1. In primary 1.
It cannot go.
Abiola, you said it cannot go back.
No, I'm not the one that say it cannot go.
No, yes, sir. That's Adeos.
Yeah, it cannot go. That's what we'll get.
Yes,
I said 2.
That's what you say. Yeah.
Yes, sir. In primary 1, that time they tell you 1 minus 5. You say it cannot go. Is it like? Then when we got to secondary school, is it like towards primary 5? Then you now discover that if you do 1 minus 5, it becomes minus 4. So maybe in the early stages, they tell you that okay, it's immutable, this and this. But still, there are times that demand mutability. Let's say you deploy a contract and everybody has access to this contract, and you want to have an upgrade. An upgrade is you are changing it, you are mutating it, yes? True or yes?
True.
Yeah, so how do you do that? Mostly you go, if we make a mistake after deployment, we'll have to go and delete. You have to go and do away with it, then you create another contract. Yes, that's the solution. But there was this guy, Nick Much. His name is Nick Much, I think. Nick Much, Mudte. Nick Much. I But it's Nick Mudge. Yes, Nick Mudge. So he wrote an EIP. Who knows what an EIP is? What's an EIP? Ten seconds. Anybody that tells me what an EIP is, I'll give you an NFT. Oh yeah, nobody don't chop NFT. So an EIP is everybody. Yes. Well, I'm listening to you, sir.
I need the NFT.
Yeah, a submentor. Yeah, a submentor, and you have to answer a question in the class because of
Can you hear
NFT.
me?
I can hear you. I can hear you, bro.
No, the student can go ahead. Can go ahead. Application programming interface.
EIP, application programming interface. EIP, it could be. It's not API or API.
Okay, it's not API. Okay, no, sorry.
EIP.
Okay, sorry, I get.
Hello, sir.
Yes.
Sorry, my bad.
Yes, sir.
Go ahead.
I don't really know much, but I have something to say. I think is something that Ethereum came. Is it that to help? Yeah, is an.
Just read what you are saying.
No, I'm not reading. I'm not even checking anything. Honestly. Yes, I'm not.
Okay. So, guys, so EIPs, what are EIPs? EIPs are Ethereum Improvement Protocol. So, Web3 is largely open source, and maybe if you find a solution to a problem and you feel it's viable, you can create an EIP. And I think guys will review it, and if it passes. Well, so this guy, Nick Mudge, he discovered a way that you can upgrade your contract. You can make contract upgradable. And he released the EIP 2535. So an EIP 2535 is what we call as the diamond standard. So in this case, contracts are being viewed as diamond, and you can cut diamond. So you can add a cut, or you can take out a cut, and it's cut at what we call faucet. So I think there are multiple things we need to read about before we do that. Okay, so I think I'll just follow. Let me just follow this. Okay, let me follow this. Article and read in the ever-evolving world of blockchain. Yes. Okay. Ethereum improvement proposals play a crucial role. So you see, EIPs, Ethereum improvement proposal. So EIPs, they play a crucial role in advancing capabilities and functionalities of the Ethereum network. One such significance is the diamond standard. It's 2535. So another assignment, I want you guys to write about 10 different EIPs each. Everybody should write about 10 different EIPs, and I'll compare it to, if you go and copy me, if two people write the same 10, there'll be problem. Or 10, I'm 25, 10, not 10 different EIPs from everybody. So the concept, before you get to understand diamonds, because in our next class we'll dive fully into diamond contracts. So let's just look at some key concepts about it, so that when I come on Monday and I'm speaking in other cities, I'm speaking French. So diamond contracts, the main contract. So diamond contract is the main contract. It's the core contract. It's the main contract. So the diamond is what you deploy. It's what you deploy first. Okay, I think you deploy the diamond cutter, or we'll get there. So it's the main contract. It's the contract which it's going to represent all other contracts that are attached to it. So it manages the other faucet. It uses delegate calls to appropriate faucet based on function signature. So what are facets? Facets are modular smart contracts. So each time when you deploy your diamond, each time you want to add, replace, or remove a functionality, you deploy a facet. So facets are like helper contracts. So you see, okay, and what it says, facets are modular contracts that contain specific functionality. A simple diamond can have multiple facets, each responsible for different parts of the overall logic. So let's say you have a giveaway contract, and Since in our given contract we're given only ERC 2220, if we want to upgrade that contract to be able to give out NFTs to the first person, maybe the first person gets an NFT and his reward. So we can write a faucet having that logic. If we want to change the logic, we can remove the faucet and the daemon will not have access to that logic again. So selectors, we have what we call function selectors. I think function selectors is the hash of the function signature. Is the it's a four it's a bytes four hash, yes. First 4 bytes of the function selector, and this is what is known as the function selector. Each function in a contract has its own function selector, and they are all unique. In this case, this is the function selector as participates. Then this is the selector for this guy too. Or is it, sorry, is the signature. This is the function signature. Then the selector is the first 4 bytes of the signature. Sorry. So this is what we call the function signature, something like this. And in each function, it has to be unique because the contract will not allow you to have two functions that have the same signature. Are we together, guys? Are we together?
Yes, sir.
Or I've thrown you into confusion?
Yes, sir.
No, Christiana said she has been thrown into confusion. So what's confusing you?
Okay. I think it's about the selectors. Like, I don't
Okay.
understand. What are we selecting?
So now what are you selecting? Okay, so now let's see. In this class that you guys are in, what do you think makes you guys unique on this call? How do I refer to each of you? It's not a trick question. How do I if I want to call you now,
Our
how do I call
name?
you? Exactly. So now imagine, so now if I want to call participate, I'll call it by his name.
Yes.
So the function signature
Yes.
is this whole line. What represents the function? This is the signature. Are you getting me? So just like your name is Christiana, I don't know your surname. You get me? Let's
Yes,
see. I think I can see Sandy John. So Sandy
Yes,
John
sir.
is a function signature for the first 4 bytes of the hash of the signature is the selector. So let me not confuse you. I can say Sandy John is the signature, and I can say Sandy is the selector. Did I make it clear or did I make it worse?
It's clear now.
You understand? So don't worry.
Yes.
On Monday we'll go deeper into it and you'll see it. I'm just introducing you. So we have the loop functions. I think the loop functions are we have the loop. Yes, the diamond loop is like a magnifying glass. It helps you to they are all view functions. Most loop functions, okay, let me read it. These are introspection functions that allow developers to query the diamond for information about its facets and the functions they provide. So yes, it's like a magnifying glass. You use it to query data. That means it shows you the information about the diamond and all its facets. For instance, maybe the giveaway is a diamond and all the functions are distributed across the facets. And let's say we're looking for the facet that has the, let's say maybe the balance of function or the participate function. When you use a loop function will help you to look for it. So the benefit of the 2535, we have the modularity. So modularization is when you break down, like, let's say we have one big contract and split this contract into modules. When you break a contract into multiple files, let me show you an example of modularization now. So you see here now, I have a contract here. Let me increase the screen size so you can see it. So where's the source? So this is the source. In the source, we have, let me close this, guys. Okay, let me close it. Good. You see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are 9 different modules. There are 9 different modules that come together to make one cake. It's not like we could not carry them and choke them in one page, but when you modularize, you break a huge chunk into little components. Are we together? So
Yes, sir.
by breaking down a smart contract into smaller facets, developers can manage and update specific part of the contract without affecting the entire system. So you isolate all these individual functions and it's easy to manage them without spoiling everything. So scalability. So Diamond enables the development of large and complex systems that can grow organically. New functionalities can be added by deploying new facets. So that's the scalability. Then upgradability. Facets can be upgraded independently. Just that's like taking advantage of the modularization. So there's reduced gas cost since the facets are updated, need to be redeployed. Only the facet here. So now instead of you to redeploy the whole contract when you want to effect a change, you just deploy the contract containing the change you want to make, then you add it to the diamond. So organization, since we have modularized our code into multiple facets, it's cleaner and easier to navigate. Hope you understand. So, okay, this one is very brief. So Diamond provide powerful framework by, so, okay, so I think there's something again we need to talk about. We need to talk about the delegate call so that you understand Diamond. Let me go to Solidity by example. Solidity by example. Because these are things we're going to use delegate call. These are things that we are going to use. So, let's delegate call comes up. So we're going to use delegate calls, and delegate call is a low-level call that allows one contract to interact with another contract. Don't click on it. At the comment. So okay, let it come up so that I'll go through delegate calls. So in Solidity, hope you guys understand what. Do you understand what low-level calls are? Do you guys know what low-level calls are?
No. No, sir.
Wow, about this guy.
Sir, sorry, please. Sir, the low level is still different from the delegate call, or is a part of it?
The delegate call is a type of low-level calls. Like there, how do you transfer ether? There's a way you transfer ether that it must go. Like it's call dot the address to and the value. So low-level calls don't get compiled. They're assembly. I think they don't get compiled. Yes, I think. So like when you write low-level, you're speaking directly with the blockchain itself, go low level, and the compiler doesn't, it jumps them, it doesn't look at them. So I think that's what a low level call is. So delegate call is a low level function that allows one contract to call another contract and run its code within the context of the calling contract. It's confusing a bit.
Yes, sir.
So okay, I'm trying to calibrate my brain and bring it back and explain it to you. So it uses, okay, good. This is what a delegate call allows a contract to do. A delegate calls allows a contract to use the logic in another contract to update its own state. Does that make any sense?
A little bit.
It's okay. Let me reiterate myself. A delegate call allows a contract to use logic from another contract to update its own state. Don't confuse it with using an interface. You know, when you use an interface, you update the state of a different contract from another contract. You guys know about interfaces here? Yeah.
Yes, sir. Yes, sir.
If contract B calls a function using an interface in contract A, the state is updated in contract A. But in delegate call, contract B will call a function in contract A, but instead of contract A state to be updated, contract A state will remain unchanged, while contract B state is updated. So for this to happen, both contracts need to have the same storage. That their storage has to be identical. As if there's a change in storage, it won't happen, or it might lead to a breakage of the second contract. So that's what the delegate cut is, and that's how the diamond does achieve upgradability. So imagine you are a contract, but you can use you can delegate calls to another contract and use the logic in that other contract to update your own state. Are you getting me?
It's making sense now.
It's making small sense. Good. So now, who can tell me what a fallback function is? When they say fallback function, what's a fallback function? Anyone? Fallback function. Nobody knows fallback function. Just guys.
So a fallback function basically is just like, so let's say how am I gonna put, like, I'm looking for a very simple it's just it. So instead of throwing an error, so it's just like a try catch, like something that throws an error when the initial function is not met. Yeah. So
okay, yes. Yeah.
Okay, this is basically not what you ought to do.
Okay, yes, I like that. Yes, but it's better than nothing. So a fallback function is the function that is being executed when you call a function that does not exist on a contract. So let's say you come to a contract and you call a function that doesn't exist. Before it throws you an error, it will check if there is a fallback function. If there is a fallback function, the contract then executes the code in the fallback function. So the main logic in the diamond contract is in its fallback function, so that by the time you call a function that does not exist, it will run the code in the fallback function. And what happens in the fallback of a diamond is that you have a function that searches. So now if you come and maybe let's say the diamond itself doesn't have any, it rarely does hold functions of its own. All its functions will be embedded in faucet. So when you come and the diamond will have access to this, it has an array that is updated in storage, where when a faucet is added, there are mappings. When a faucet is added, the mapping is updated, tracking each faucet to its function selectors. Don't be confused. Each faucet is a contract, and every contract has its own functions. So each time you add a contract to a diamond, the diamond takes note of the contract address and all the faucets that contract holds. Does this make sense?
No.
It doesn't make sense. Okay, let me break it down for you. So I said a diamond contract is a contract that can be upgraded, yes?
Yes.
And it is upgraded by adding other contracts to it. But they will all share the diamond. The main address is that of the diamond, and all these other faucets will be added to the diamond. So you upgrade the diamond by adding another contract to it. Do you understand this bit?
Yes, I understand. So sir, my question is that from all what you're trying to say, you cannot remove, but you can add.
You can remove, you can add, you can
only
remove,
by fallback function.
And you can replace. Okay. Yeah, jumping. I'm trying to take a step at a time. You're running back.
Okay.
So now you understand that a diamond can be upgraded by adding other contracts to it.
Yes.
So when you add other contracts to the diamond, so what does the contract contain? It contains function, yes?
Yes, sir.
So now every contract that wants to be added to the diamond has its own function inside it. True or yes?
True.
So each time a contract is added to a diamond, the diamond takes note of the contract address and all the functions that contract contain. It has a mapping that it takes note of the contract being added and all the functions in that contract being added. Does this make sense?
Yes, sir.
So you don't add a random contract to a diamond. Once you add a contract to a diamond, the diamond knows that contract. Do you get that?
Yes, yes, I do.
So in the fallback function of the diamond, the fallback function is only executed when you run a function that does not exist on a contract. Do you understand that bit?
Yes. Understand.
Good. So now the logic in the fallback function of the diamond is to be able to search for the function you call that doesn't exist. It will look for which of its faucet has that function because it's already tracking every faucet and every function it has. So by the time you call a function that does not exist, because the diamond itself won't hold any function, it can hold, but it won't hold any function that can be upgraded. So by the time you come to the diamond and you say you're looking for, maybe you're looking for participate, the diamond doesn't have participate on its own, it doesn't have participate in its own contract. But its fallback function now, the participated will be redirected. The function you call participate will be redirected to the fallback function. So the logic in the diamond's fallback function is okay, this is participate. Which contract has participate? It goes through its mapping and he finds the contract that has that function you call. Let's say contract A has participate. Be like contract A is participate your function. Like let me see, yeah, it's mine. Okay, what's the logic of participate? Then contract A gives the diamond the logic of participate. And remember, delegate call is you using the logic of another contract to update a state in your own contract. So it executes the logic in that contract A, but it uses it to update its own state. Confused?
No, sir.
So you get it a little.
Yes, sir. It's going to make sense.
Okay. So yeah, so that's how that's how it works. That's the major way the diamond standard works. So the main diamond contract is being deployed without any logic, but it's being deployed without any function. But peradventure is to deploy a diamond with a function. The function you deploy the diamond with will be immutable. You cannot change that function. Any function on the diamond itself cannot be changed. So mostly the logic of the diamond is in its fallback function. Does it make any sense, please?
Somehow, sir. Yes, sir.
Yeah, somehow. Don't worry. On Monday we'll visit it explicitly. So I'm just introducing it to it. So I think we have 7 minutes, and so I think I'll stop the confusion here for today. So you can I want you to go and read about the EIP 2535. I want you to read it extensively, understand the concept of delegate calls, modularity, proxy contract, faucet, the diamond itself, the diamond loop, and it's very interesting. Like you will enjoy it because the diamond, no matter how many faucets you deploy and add or remove or replace in it, it maintains one unique address. So the issue of just imagine giveaway now. We give people an address that hey, oh, this is the address we're using for giveaway. Then maybe after 2 days we discover that there's something wrong and we want to change something. Normally the normal way it means we'll go and redeploy another contract, and it means us redeploying another contract and start giving out another contract address. Yes?
Yes,
But with
sir.
the, but with the diamond contracts, we don't do that. We just update or upgrade the contract. So I think our time is almost up, and you're enjoying today's class. At least see some reactions. Nobody enjoyed it too.
Sir, we enjoy the class.
So now we try.
We give you 3 bossa.
Today?
Bossa, bossa, bossa.
Oh,
You really
hope
try.
I didn't leave you guys more confused than I met you guys earlier today.
No, you've tried. You've done your best.
We'll need to go back to the.
Yes, sir.
Can we get the link to
To the
the upgradable contract? Yes, sir.
Yeah, I think it's almost everywhere. Yeah, okay. I want you to follow this guy. This is 3.5. This is about delegates. This delegates calls. You need to understand delegate calls because that's how it works. Then, yeah, where is it? Let's see if I go back and I can get that for you. I used to have my own. I think I do have my own. And if you check my repo, I have a diamond contract I wrote. So you can go through it. Let me give you guys a link to it. I think so that you can start browsing through it, and it is well indexed. Like I commented everything, like I explained every line about the diamond standard. So it's mostly self-explanatory. So if you want to have a peek at it before Monday, you can be my guests. Let me share it with you guys. Because I really love the diamond concept. You know, it's sweet like that. Yeah, I think so. I did it with block. Yeah, I thought some guys thought block header did it together. This was just like last month. Yeah, quad 6, block header quad 6. Let me see. No, but the problem is the assignment I give them is inside here. So if I'm giving you this and I'm giving you everything, no. So if you want to have a peek at what a diamond looks like, this is what the diamond contract looks like. You see, this is a delegate call. It's low level. It's in assembly language. So this is a delegate call. So you see, most of the function. This is the fallback. Fallback function. It houses the main thing. So this is an example of a mutable function. This function will not be able to be changed. And aside the fallback, it's just the constructor. It's just the constructor. We have the constructor. Then we have an array of diamond cards. We have another array of function selectors. Well, let me share. Then I'll see you guys on it. So cheers, guys. Any question before I bow out? Okay, so no questions. So,
okay,
now.
thank you, Mr. Aji. Take care, sir.
Thank you very much, Ikupe. See you
Okay, sir. Bye-bye, sir. Okay, sir.
Bye.